All right, welcome to section 2.3. We are doing two different things today. One is to review concept of slope, and then the second part will be to review the concept of slope, intercept, form. There'll be two videos. This first video today is going to focus on slope. All right, so just a quick review. And actually, before I go through this, I encourage you to take a minute and see what you remember about slope. So look at this picture, see what you remember from that. And then also, if you want to try some of these other questions on the front side here about like finding slope, maybe try those first and then I'll go through them in this video. All right, so I think it'd be better if you try it first and then instead of just having me do it for you. So what do you remember about slope? All right, now that you've tried it out, just a quick review of what is slope. The most common thing you hear is slope in the world of graph. That's what students most seem to remember, and they usually say to me slope is rise over run. All right, and so this just means that if you have a visual picture of it, a graph, you can look at the up or down change called vertical change. That value goes on top, and then the horizontal change goes on the bottom. So like in this example, if we imagine that it went up about, based on the tick marks there, maybe it went up like 3 units, and then it went to the right 4. That's a slope of 3/4. Okay, over in equation world, slope is just a value in the equation. So this is a linear equation, a straight line, and the number that's paired with x, whatever is right there, that ends up being the slope, the steepness of the graph. All right, in a table, this is the one I find students are least familiar with, is it's just the ratio of change. So slope, another way to think of it in a table at least, is it's a ratio of how the y variable is changing compared to how the x variable is changing. So in our table, in this case, we can see that as our x values, which is actually time in this case, but it's in the place of x, is going up 1, and our money or whatever this side is going up by 10. Okay, so that ratio of 10 to 1, that is the slope for that table, right? And graphically, it'd be a really steep line. But in a table, like the thing I want you to remember here is in a table, it's just a ratio of change between the two variables with y change on top, x change on bottom. All right, getting to the other problems then on the sheet. All right, so when you actually want to find the slope, when you're given a graph like this, not the table or anything, just given a graph, you want to find like whole number of points and then find what is the y change to x change between those points, right? And sometimes it's hard to tell. This graph's not super great about where the points are exactly, but you want to find one where it's easy to tell the coordinates. And then you can sort of draw a line. So in this case, I'm going up 4 and right 3. And it wouldn't matter which points you picked. If I picked these 2 points, I went up and over. Either way, that's a ratio of 3 to 4, where, actually, I messed it up, didn't I? That's not it. So the y change has to go on top. So it's 4 to 3 because we went up 3 and then up to the right. Sorry, went up 4 and then to the right 3. So the slope is 4 to 3. All right, next slope is a downhill slope. So when you're going down, it's going to be a negative slope. So it's the same idea, find some whole number of points. And this time we're going to go down and to the right. Okay, and because we went, I always go to the right when I do my slope. But because I went down, this is negative. So it's the y change of -2 to an x change of +4. And if we simplify that, it looks like it's -1/2, which we probably could use a different pair of points here and got that -1/2, like so. All right, so besides positive and negative slope, there's 2 other types of slope. They're sort of special cases. So this is a completely flat line. And I always think of this little dude that's walking on the line here. And if he's not going up or down at all, that's a 0 slope. So 0 slope. All right, I think on the test, this will actually show up as a ratio. So we talked about like ratio is like the y change to the x change. So this actually has a 0 on top, right? There's no up or down change, right? So it's 0 on top, and then if we just pick 2 points, you really wouldn't matter which 2 you pick. But if I pick those 2, then I'm going, say, right 3. So this slope as a ratio is just 0 over 3, which just simplifies to 0. All right, and contrast this with our last slope, which maybe you remember the word here. When it's straight up and down, I think of this dude trying to walk on this, and he's not going to have a good day here. He's going to be falling and going splat. right? So this is called an undefined slope. It's so steep we can't even define it. Okay, and as a ratio again, if we look at a couple of points, any 2 points on the line, we'll see that let's say we just went down 2 between those points and we didn't go side to side at all. All right, and when this happens, we have like a divide by 0 situation, which is undefined. Right? If you try and do this on the calculator, you'll get an undefined value. Just a quick way to remember all this. Here's a little picture that I like to use where we can see that we have the different slopes here. The negative one, where you're going downhill as you go left to right. So always think of it in terms of going left to right. That's negative. If you're going uphill, it's positive. And then a flat line is 0, and then fall into your death over here. That's an undefined. So, okay. One other thing to mention with slope. This is a skill you've probably done before. It's just a formula. If they give you a pair of points instead of a graph and ask you to find the slope, you can just label these little points, like the 2x points you call like x1 and x2, and it doesn't matter which is which, and then y1 and y2. And then in this situation, to find the slope, there's this little formula that I'll show here, which you might want to copy down on the page. So when you have 2 points like this, you subtract the y's on top, subtract the x's on the bottom. You have to keep the order consistent. So if I'm going to use these two as my x and y2, they would come first. So for this particular set of points, on the top, I would do -3 first for my y, and then minus the other y, which is -1, so minus -1. And then when I do my x's, I have to do this as x little 2. So it's going to be 8 minus -2. All right, and so these will turn into pluses. So this will actually turn into a +1 and a +2 because minus negatives are just adding. So on the top we would have -2. On the bottom we would have 10. Okay, and this just simplifies to -1/5. All right, if you want one more practice of this, you can try it on here. If you feel pretty good, then you can just skip the rest of this video and go on to video number 2. All right, so if you want an explanation quick, you just minus the y's on top, and it doesn't matter the order. But I think this is the way students traditionally do it, is they subtract in this order for some reason. They do 7 minus -4, and then we would take this 2 minus 2, and we would get 11. Oops, we get 11 over 0. And then we just have to remember that that's our undefined slope. Sorry about that 2 there. I don't know what I'm doing here. 11 over 0, and that'll get us the undefined slope. So this is what it'll look like, I think, on the test. You'll have to remember those special cases, that if you get the 0 on the bottom, it's undefined. If you got 0 on the top, it'd be a 0 slope. So if we had ended up with just 0 over 11 instead of what we actually got, that would just be the 0 slope. All right, that concludes the first part. Second part is a separate video on slope-intercept form.